try to show a little example regarding the velocity of light in one frame of reference versus once it hits a media and then continues on after it leaves the media. So if you can see this. So the light from this laser pointer is propagating at the rate of c. It's traveling at 186,272 miles a second from this laser pointer. And it's hitting that glass. If I have it stationary to that glass, it's hitting it at the speed of light, the rate of c. But if I have the laser pointer and I approach it towards the bottle, let's say I'm approaching it at 100 miles a second, then the speed of light from that particular laser is going to be at c plus the velocity that I am approaching the glass. So the light from the laser is traveling at c relative to the laser, but if I'm moving the laser towards the bottle, then you have to account for the speed that you're moving the laser pointer towards the bottle. So c from the pointer, but c plus v. So if it's going at 186,272 miles a second from here, and it's traveling 100 miles a second here, it's hitting at 186,372 miles a second by the time it hits the bottle. Okay, but as soon as that hits the glass, the light from this laser pointer diminishes to 0, since the electrons making up this glass absorb this primary incoming light, and then as it crescendos to nothing, a secondary light, as the initial light diminishes to 0, the secondary light crescendos as an equal and opposite reaction. So the speed that the light is traveling, as soon as that from the glass inside the water, is traveling c. Regardless how fast this laser pointer is traveling to or from that bottle, the light inside of the bottle is traveling the speed of light, regardless of how fast this is approaching. Now, the light from this is traveling c plus v, but the light within here is traveling c. And a light that hits the paper on the other side is also traveling at the rate of c, relative to the other end of the bottle that it's being re-emitted from. So you got the initial light coming in at a given speed. It hits the bottle. The bottle has its own refractive index. That's a secondary light. But then as it leaves the bottle, it's a brand new light yet again, traveling relative to the bottle. So regardless of how fast the approaching light is coming in, it's always going to be the rate of c on the other side, serving the illusion that the velocity of light is the same in all frames of reference, serving the illusion that the constancy of light is the same in all frames of reference. But it's not. So that is that particular point. So the first light approaches, gets extinguished and absorbed by the electrons. The second light re-emits, the electrons re-emit a secondary light, and then it extinguishes again on the other end, and then a brand new tertiary light, third light, actually hits the paper.